Okay, so the question I had for you last week was if I were to fill this pyramid with water and pour it into here, how many of these full would go into my prism? So we had a 2, we had a 3, I think we even had a 4 as a guess. So or between 2 and 4, yeah. So whoever said 4, who said 4? Okay, would it be okay if I demonstrate this just right over here?
Chris said this.
Okay. Man, ruined my presentation. Okay, so let me bring some water over.
Oh,
Yeah, she's gonna do it. We're gonna see how many.
I feel like it's not even that much. It'd be fine because mine is ready.
What a trooper. All the names of geometry here. So I'm going to fill this up. So here's one full. Here's one.
Oh, my.
Now I have more water. There's one.
Wait, is it with the triangle in it? No.
No, I'm just, how many of these pyramids full? Okay, so we're at 2 already.
It's gonna be 3.
Some more water. I have more water. I need to be careful. I was more careful second period. There's a little bit of ice spilled out. There it is. So it did take 3 of them.
Oh my god.
So we learned, this is before break, that the volume of this guy as well as the same relationship holds for this one. So the volume of that one and this one, the cylinder is this base times height. And the relationship is that if you have a pyramid with the same base area and the same height, it will take 3 of these to fill that. So the volume formula for this is going to be 1/3 of that. Same thing with the cone and the cylinder.
Is the cone the same?
Yeah, it would take 3 of these to fill that, isn't it? It doesn't look like it, but it will. We could demo it, but here. But it would take 3 of these full. It never looks like it. It is. I always get guesses between 2 and 4. Usually people guess 2 on the low side, 2. But until I pour that first one, they go, oh, maybe it's going to be more than 2, because it doesn't go up to at least half full. But it is. It's kind of an optical illusion here. 3 minutes to pour this water back into here. A lot of water that thing holds. Put this back. I need it 6th period. Don't give away the secret for 6th period. Cheap napkins from whatever, I don't know where it came from. No, so good. All right. So we discovered through the water experiment that 3 of the pyramids or 3 of the cones will fit into their counterpart of the prism or the cylinder, respectively. And let me put this away. So our volume formula is volume equals 1/3 base times height, where base is the base area and h is the height. And of course, for the cone, the base area is a circle. So let's go ahead and try this pyramid here. It says find the volume of the following pyramid with a square base. So we have volume equals base times height. Well, the base in this case is a square. So my base area for this square would be 10 times 10. what did I forget here? 1/3. So volume equals 1/3 the base area times the height, which is 12. And so if you want to, you could go off to the side and calculate the area of the square, 10 times 10, or 100. Do it that way, and then just plug the 100 in for B. Okay, or you could do it all at once. Either way. So I have 1/3 of 100 times 12, or exactly 1/3 of 1200, which will be 400 cubic meters. It's really easy to use, especially if the base is a square. I have a problem in your homework where the base is a hexagon, so you have to find the area of the hexagon. Any questions on this one? Think you could do this one in your head?
Oh, wait.
So you find the area of the base, which in this case is a square, so it has an area of 100. Multiply it by the height, 12, and then divide by 3. All right. So you think you could do this one in your head? 1/3 base times height.
Oh, is this the same one?
It's similar. What would the base area be on this one? 36, right? You see how we got that?
So it'd be 36 times 8.
It's a square for the base. So 6 times 6 is 36.
Oh, I thought the A was like 6.
So 36 and then times 8. So what I would do is do 1/3 of 36, which is 12, and then 12 times the height, 8, is 96. So, pretty easy to do, especially if the base is a square. Now, if the base were a hexagon, what formula would you use for the base instead of side times side or base times height? Yeah, it's 1/2 the apothem times perimeter. So that'll show up. And I'm going to let you work in class on that today. So you get a chance to try that in class and figure it out in groups. So easy formula to use as long as you can calculate the base area. Now, one thing that's been a theme through this unit when we're looking at surface area or volume of pyramids or cones is the Pythagorean theorem keeps showing up, right? Because, for example, for this one, to find my volume, the base area is not a problem here. It's just going to be pi times radius squared or pi times 5 squared. But when I go to find the height, I have to use the Pythagorean theorem to find my height. Right? So my height is not the 13. It's really close to 13. But if I draw the height straight down to the center of the base and then use the Pythagorean theorem to find my height, then I can plug it in. So I have 5 squared plus h squared equals 13 squared, or 25 plus h squared equals 169. Subtract the 25 over.
Wait, is this one?
Yeah, this one's on there.
This one?
Yeah. It's on your note packet. And then the height equals 12 meters. As a matter of fact, some of you probably saw that as soon as you saw the 5 and the 13. This is a Pythagorean triple as well. A lot of triples will show up on these worksheets. Okay, so be looking for the 3, 4, 5, 6, 8, 10, 5, 12, 13. Those 3 show up a lot. So I'll save you a little time. But the Pythagorean theorem is what you're going to use to find either the height, if you're doing the volume, or if I were asking for the surface area, if you look at your surface area formula, it involves the slant height L. And so if that were missing, you'd have to find it. So let's see, you got 1/3 pi times 25 pi times 12. 1/3 of 12 is 4. 4 times 25 is 100 pi, or approximately. It's 100 times 5. 100 times 3.14 is going to be about 314. So the nearest whole number, it's 314 cubic meters. So that's the volume of the cone. Now cones are nice because you know the base is going to be a circle, right? It's going to be pi r squared. The pyramid, it could vary a little bit, but it's going to be a square or probably a hexagon, one of those two, the ones I give you. But it could be any regular polygon for the base, the pyramid. Just hope for squares. Square-based pyramids are probably the most common. All right, see if you can find the volume of this shape and round to the nearest whole number. So you can do that on your own.